All right, guys, so in today's video, we are going to be looking at how you name what's called binary compounds. And in order for us to understand how to name binary compounds, we're going to have to look back at our periodic table that we labeled some charges over for homework a couple of days ago. So down at the bottom of the screen, we're looking at the charges that I asked you to put above your periodic table. So we see that in group 1, we have a +1 charge when it forms an ion. Remember, ions are atoms with charges, atoms that have a charge. And so the charges that we've written above the periodic table are going to be the charges that the atoms in that group or that family take on when they form an ion. So group 1 is going to form positive ions with a charge of +1. Group 2 is going to form positive ions with a charge of +2, and so forth across the periodic table, as we've already seen. So when we're looking at that periodic table, we need to figure out what groups or families can form compounds together. And when we look at that, we know that we're looking at charges, and we know that opposite charges are going to attract one another. And so we see that groups 1, 2, and 13, also known as 3, but on your SOL, it's going to be referred to as group 13 because they've added group numbers to the entire transition metals. We're going to see that groups 1, 2, and 13 can form compounds with groups 15, 16, and 17. Groups 14 and 18 are going to be a little bit different, and they're going to do their own thing, and we're going to talk about those a little bit later in the year. But right now what we want to focus on is the idea that atoms of opposite charges can form compounds together. So based off of that idea of opposite charges being able to form compounds together, I want you to take a look at the 3 scenarios presented here, and I want you to identify whether or not you think a bond could be formed between the 2 atoms that are listed in each question. And once you have input your answers, continue the video to see if you are correct. So when we look at the first scenario, can calcium form a bond with lithium? We know that calcium is going to be here in group 2, and lithium is going to be here in group 1. So they are both going to have positive charges, so the answer would be no, because they are both positively charged. Similarly, when we're looking over at whether or not oxygen can form a bond with fluorine, we see that both of them are going to have negative charges. So the answer to that question would also be no, because they are both negatively charged. So they're going to repel one another. And looking at our third example, we're looking at whether or not sodium can form a bond with fluorine. So we're going back over here to F. And the answer to this one would be yes, because they are oppositely charged, and we know that that opposites attract. So we've thrown around this word bond a couple of times in the video, but we've never quite defined what bond we're talking about between these atoms. And the bond that we're talking about is referred to as an ionic bond. And ionic bonds form between metals and nonmetals, which we should see on our shaded periodic table. We see that the metals are going to have the positively charged ions, and nonmetals are going to have negatively charged ions. And in ionic bonds, the electrons from one atom are being transferred to another atom. So thinking about the charge of an electron being negative, I want you to try and figure out which atoms, the metals or the nonmetals, are actually transferring their electrons to the other atom. Which atom, the metal or the nonmetal, is losing an electron and which atom is gaining an electron. So hopefully you picked that the metals are going to be the atoms that are losing the electrons, which is why they are having a positive charge, because they now have more protons than electrons. And hopefully you identified that the nonmetals are going to be the atoms that are gaining the electrons because they are gaining those extra negative charges, those extra electrons. So all of the compounds that we're going to be talking about in this video are going to contain what we call monatomic cations and anions. So I want you to remember from that homework again that a cation is a positively charged ion and an anion is a negatively charged ion. And when we're talking about monatomic, we're talking about single atoms. So we are looking at one atom bonding, one cation bonding to another atom, which is why we call it binary, because that prefix bi means two atoms. So we're looking at two atoms, one cation, one anion bonding together. So now we're going to look at how do you look at a formula and come up with the name of that compound. And so there are a couple of rules to follow in order to do this. And the first one is being able to identify your cation or your anion. So being able to identify the metal or the nonmetal. And in naming, the cation name is always going to come first. As we see here, cation always comes first. And this part's really easy. For the cation, all you're going to do is simply write the element name as it appears on the periodic table. So some examples that are here in the video are calcium, hydrogen, magnesium, potassium, beryllium, anything like that. You're going to write just the name as it appears on the periodic table. The anions are going to be where it gets a little bit trickier, because with the anions you are going to use the element name root, so the big chunk of the element name, but you are going to replace the ending of that name with ide, I-D-E. So sulfur is going to become sulfide, oxygen is going to become oxide, chlorine is going to become chloride, bromine is going to become bromide, and so on. And it becomes a little bit hard, especially starting out, to identify where that root name is. And so I don't expect you guys to be perfect at that just yet, but we're going to get lots and lots of practice, so it will come to us a little bit easier eventually. So with these rules in mind, I want you to try and name the compound at the bottom here, NaF. How would we name that? So the first thing we have to do is identify the cation, which is going to be our sodium, and fluorine is going to be our anion. And so we know for the rule of the cation part of the name that we leave it just as it is. So we're going to have sodium. And then for the anion part, we have to keep the root of the element name. So we're going to keep that fluor part, but instead of it being fluorine, we are now going to replace that INE ending with an IDE. So we're going to have sodium fluoride as our answer. So here are 4 other examples that I want you to go through, and I want you to try and come up with these compound names on your own, and then check your answers. So in all of the examples we've been looking at so far, we've been seeing a 1-to-1 ratio of cation to anion atoms. But that's not always going to be the case, and here's an example of where it is not the case, where we have MgCl. So the first thing I want you guys to do is go ahead and name this one for practice as well. And we should see that the name for this is going to be magnesium chloride. But we see that there is this subscript of a 2 in the formula. And so I want you guys to think about, what do you think that 2 is going to indicate? What does it tell us? Well, what it tells us is that there are 2 chlorine 2 chlorine atoms for every 1 magnesium atom. Notice that having that subscript doesn't affect the name at all. We still name it in the exact same way, with the cation using the element name from the periodic table and the anion using the element root name with the changing of the ending to "ide." But why this happens is when we see magnesium on our periodic table has a charge of +2, but chlorine only has a charge of -1. So in order for our compound to be happy, it wants to have an overall charge of 0. And in order for that to happen, we need to have 2 negative charges from the 2 chlorines to cancel out our 1 magnesium atom that has a charge of +2. So hopefully now you're feeling pretty confident at being able to look at a binary compound and tell me its name. But we are also going to have to be able to write formulas. So the next part of this video is going to be how do you write binary compound formulas. And there's a couple of steps that are going to make this really easy. So the first thing that you're going to do is you're going to write the symbol for each element that's going to be in the compound, and you're going to write the charge associated with it. So aluminum is in group 3, so it's going to have a +3 charge. Chlorine is in group 17, so it's going to have a -1 charge. Remember, you can write the negative sign or you could write -1. Either one, it doesn't matter. So now what you're going to do is you're actually going to crisscross those charges, and instead of having them written as charges now, we're going to write them as subscripts. So we're going to end up with Al1 and Cl3. So again, we're just taking that charge from the different elements, we're crisscrossing them, so we're trading which atoms they belong to, and now instead of a charge, which is written like a superscript, it's written super high, we're going to write it as a subscript, which is written low, like a little number. And the last step of writing formulas is going to be combining the 2 atoms with their subscripts together. But the part I want you to recognize, or I want you to kind of realize here, is that if it has a subscript of 1, we never ever write it. So the final formula here would simply be AlCl3. Notice I didn't write that 1 as a subscript, it just disappears. So to finish out this video, I want you to take a look at these 3 compounds here: calcium bromide, sodium phosphide, and magnesium oxide. And I want you to try and write the formula. Remember, when we're looking at this, we're looking at a ratio of atoms, what ratio we need to have in the compound. And so if we have any subscripts that can be reduced, you do need to reduce them to the lowest possible terms. And the only one that I'm going to walk you through is going to be magnesium oxide. So for magnesium oxide, we know that we have Mg with a charge at 2+. We have oxygen with a charge of 2-. We're going to crisscross those charges just like we did on the previous slide. So now we're going to end up with Mg2O2. And because these subscripts can be reduced down, we're going to reduce this final formula to MgO, because we only need 1 magnesium oxide with a charge of 2+ for every 1 oxygen atom with a charge of 2-, or oxygen ion with a charge of 2-, which is why it reduces down to a final formula of MgO. And that is binary naming.